the paper title report here is classification of different phenotypes of refractory epilepsy using big data analysis. Basically, in this paper, I want to classify different phenotypes of drug-resistant patients. So I probably don't have time to talk about all the sections I put in here. We can start look at the data. So basically, the data is coming from the TA. It's prepared by the instructor, and this is a simple statistic for the initial statistic for the data set. So basically, total patient is 12,000, and finally we have 5786 patients are epilepsy patients, and also only 283 patients have a AD number bigger than 4, which we defined as the DRE patient. And other epilepsy patients are non-DRE patient. So to extract feature, I follow the timeline of each patient's history. So basically, I extract about 18 features. So such as the age of a patient and the sick age, which is the patient first take his AD drug, and delay time is when this patient get his first events. Between the first event and the first time he take the AED, that's called the delay time. And the other features are straightforward. Then, after I have the features, then first I did some kind of visualization. So I plotted these features against the DRE or non-DRE. So from here, this figure, you can see the AD number actually is quite correlated with the DRE, non-DRE. And this is, of course, it's obvious because I defined the DRE, non-DRE based on AED number, so I shouldn't use this for the prediction model. And also, you can see here, gender probably doesn't provide any information for any kind of model. So then the second, I did a feature selection. So this is based on the random forest score. So you can see from here, when I only choose top 5 features, you can get like 98%, more than 98% accuracy. Basically, that means the top 5 features can perfectly predict, classify the DRE and the non-DRE patient. So these are the importance of the features from highest to highest to lowest. And then to visualize how the data look like, how this DRE, non-DRE patient data set look like, I did a PCA. So I plot the PC2 component to the PC1 component in this figure. So in the blue dots are the DRE patients, and the red dots are non-DRE patients. So you can see there, they really have some kind of difference between DRE and non-DRE patients. That gives me some confidence that we actually can do some kind of prediction based on the information we have. So then the next, I did a random forest to the features. I extracted, basically I only use the features, the events, patient before patient takes a second AED. So our criterion is the patient taking 4 AD, bigger than 4 AD will be DRE. So once he before he take the second AED, you still cannot know is a DRE or non-DRE patient. So if this prediction is workable, they will give us very good information, estimation about in the future if this patient will be DRE or not. So I use a random forest model, use 500 trees, and it seems like the prediction is quite good. The estimation of the error rate is 0.5%. Here is a computing function. The specificity is 99, around 99%, and sensitivity is 100%. So the prediction is almost perfect. And the importance of the features, as you can see here, so the AD1 time, and this first drug time, and the second drug dose and the second drug time are contribute the most information to the prediction. So they are the most important features. So basically, if we just take a couple of these top 3 features, you probably can predict DRE or non-DRE pretty good. And also the gender, as you can see here, doesn't contribute too much. So the next, I took all the DRE patients, and then I do a k-means clustering. So this k-means clustering actually, you cannot really have a criterion to choose how many how many clusters you want to choose. So here I did a k equals to 3 first, and as you can see here, the one group has only 2 patients, and then I decided probably k equals to 2 will be better, and indeed the clustering looks a little bit better. And you can compare distance, mean distance of each cluster, and when cluster k equals to 2, actually the mean distance is smaller than cluster k equals to 3. So that means set cluster k equals to 3 is a little bit better than k equals to 3. Then I do a statistical across the 2 clusters. You can say that these 2 clusters does have some kind of different characteristics. So such as the age in these 2 clusters are significantly different, and sick age, delay time, AD dose, then these are significantly different between 2 clusters. So what caused this kind of difference, and what's the fundamental mechanism behind this is probably need a further study research. And thank you. This conclusion is time between first. So these features can usefully effectively predict the DRE patient, and also DRE patient can be classified as 2 groups. Okay, thank you for listening.